Hello everyone, hello friends. Again, let us try to understand alternating current or AC. By the way, we have a lot of electrical signals around us. It is of many forms, but only few are studied in detail. In our industry, the electrical practice, so we normally and commonly use signals in power generation and utilizations. Our world really needs a mega-sized amount of electrical power needs. To meet this, batteries are not capable of supplying these demands. But batteries also plays an important role in the industry. So we created the generators. By the way, these are the machines that supplies huge amount of energy, of electrical power. It has the capability. So therefore, by these machines, the world needs of energy demands can be met. And it operates on this basic principle that the poles, which is the north and the south, creating a magnetic lines of force, and you subject a conductor between that and start cutting that magnetic lines of force. The electric charges inside the conductor will move in one direction, and thus it produces electricity. And the electric signals are categorized into three. We have the constant signals, periodic, and the alternating signals. For the constant signals, a typical example of that is the direct current. If you will notice that it is represented by a straight line starting from 0 to infinity, or it sometimes will goes down to 0 because of the energy depletion within the battery, because normally direct current is from the battery or cells. And also the periodic signals, it is periodic because for every period the form is just repeating. For example, here we have a positive ramp or a sawtooth waveforms. You'll notice that for the first period, this is the figure. It reaches the maximum point here and then it plummets down. So again, for the next period, it is the same, and so on and so forth. So this is the positive ramp, and the other one is a negative ramp. It is on the reverse or the other side. It is leaning on the left. The positive ramp is leaning on the right. So the parts are here. We have the so-called slow positive ramp, steep decay, and so on and so forth. Okay. Another typical example of periodic signal is the rectified sinusoidal waveform. You'll notice here that only the positive cycle are repeating on each period instead of going to the negative cycle. It goes up by the introduction of our electronic devices. And the last one is the alternating signals. So we have here a sinusoidal waveform. So it is alternating because for the first half cycle it is positive, and the other half cycle is negative, and it is repeating for one period, one full cycle. Okay, so now we normally use the alternating signals because actually has an equal points in a circle. So if this one is the time, so it also has an equivalent specific value at a specific time in our sinusoidal waveform. Okay, so we can represent the equation, an equation for this waveform. If it is y sub t, okay, so we can say that y sub t, if we name this as y in t, no? Because t here is the time. Okay, at that is a specific time, you can actually get the value. We call that instantaneous. So we represent this signal into this equation. Ym here is actually the peak value. It is the peak point here. And omega is the frequency in radian per second. And f is the frequency also in cycles per second. And t is for the time. So this is the equation. Yt is equal to ym sine omega t. So again, omega is actually 2 pi f in cycles per second, but in the radian per second, that is omega. So your f here can be substituted by 1 over t. So when you multiply 1 over t to 2 pi, it becomes 2 pi over t. Okay, so we can get the average value of the sine function. So how do we do that? We just consider the half cycle and we set up this equation. So that is equivalent to average y is equals to 1 over t over 2, which is the half cycle. And we get the area of the half cycle here. So the equation of y in t is ym sine omega t dt. So to get the area of this figure here, we integrate that. We introduce integration. So that is from 0 to t over 2. Okay? So let's try to integrate that one. We have the integration of sine u du is equals to negative cosine u. So we place to the other side of the integration sign the variable y sub m, and we place 2 on the numerator, and then we take the integration of sine omega t. It will give us negative cosine omega t, okay, times negative, because this is negative. So the result will be this one, negative 2ym over 2 omega cosine omega t dt from 0 to t over 2. Okay, but since again this is our value for omega, 2 pi over t, so we have this one. Okay, so we instead of writing omega here, we substitute 2 pi t. So we do it here in cosine omega t, 2 pi over t, and small t here will be substituted for t over 2 point. Okay, minus the other point here, 0. So cosine 2 pi over t times 0. So you will cancel out this one, 2 in the numerator and 2 in the denominator, also with t. So what remains is pi. So cosine pi will cosine pi is actually 180 degree. Now if you get the cosine of that, it gives you negative 1. And for this part, for this term, we have cosine 0, because 0 is multiplied to these values or this term, it will become 0. So cosine 0 is actually positive 1. So this will be the result. You just copy this one, and negative 1 minus negative 1. So this will become negative 2. Negative 2 times negative 2, that will become positive 4. Okay, but we substitute here again 2 pi over t. It will be cancelled out here, t and t. So also with the 2, and what remains is negative 2 times negative ym over pi. So the result will be this one, and negative 2 times negative ym, that will be positive. So the average y value is 2ym over pi, or if you'll get the decimal value, that is 0.637 ym, or the maximum peak. That's for the average value of sine function. For the root mean square, which is the effective value, again we use the same value for this curve, which is y and t, ym sine omega t. Okay, so the RMS value is the square of this one, of y and t, integration of that one, and then after getting the square of this one, you take the square root. So this will be the value of that. So that is the square root of 1t, integration from 0 to t, ym squared, peak value, sine squared omega t dt. Okay, now if you will integrate this value, you need to first convert this to this kind of trigonometric value for easier integration. So you take sine squared u is equal to 1 minus cosine 2u over 2. Okay? And then you placed it on the left side of the integral sign. It now become y squared m over 2t. Okay? So 2t here, 2 here, it comes from this divided by 2 of the trigonometric sign. So you place that on the left side of the integral sign, and then you start integrating 1 minus cosine twice omega t. Okay, so this value comes from this one. Okay, and then integration of 1 is simply t. Integration of 1 dt is t, and when you integrate this one, you know that the integration of cosine u du is sine u. So you introduce it here, and then you find this one. Okay, the integration of this value is t minus 1 over 2 omega over sine twice omega t from 0 to t dt. Okay, you introduce now t first to this relation, and also after that you introduce 0, and also substitute the value for omega, which is 2 pi t. So you get this one for t. This is the part for t, and for 0 you get 0. Okay, and then for further simplification, ym is y squared m over 2t times t remains, square root of that, and then you just again simplify that one, you cancel out t and t. So what remains is this one. The square root of y squared m is y m, and then this one is cancelled out, t and t, and the square root of 2 is square root of 2. So this is the RMS value for the sinusoidal waveform. So if you are going to get the decimal value of that, it is 0.707 times the peak value. For the conversion for common waveform, for the sinusoidal waveforms, the RMS is always equal to 0.707 times the peak value. For the average, you multiply the peak value to 0.637, and peak to peak is just twice the peak value. For this form, square waveform, the RMS is always equal to the peak, the average value is always equal to the peak, and then the peak to peak is twice the peak. For the triangular waveform, the RMS is 0.577 peak, and the average is 0.5 peak, and the peak to peak is twice the peak. Okay, so for that kind of waveforms, it is very easy for us to get the effective value and the average value. But for the arbitrary waveform, it is very hard for us to get the RMS and the average value. So there is no simple conversion for the arbitrary waveform. Thank you.